So in this video, we're going to talk about short-run equilibrium and perfect competition. So we'll talk about three different types of short-run equilibriums. One where the firms are making profits, one where they're just breaking even, and one where they're going to make losses. First, let's review the assumptions of perfect competition, and then we'll talk about the things we need to be true to be at short-run equilibrium, and then we can draw the graphs for the three short-run equilibriums. So let's first talk about these assumptions of perfect competition. So the first is that there's many buyers and sellers. Two, homogeneous goods. So this means all the goods are pretty well the same thing, so there's no differences in kind of like branding or something like that. They're kind of the same goods. All the firms are selling the same thing. And the third is that firms can freely enter or exit the market. And these first two are quite important because what they really mean is that firms are price takers. In the sense that they don't get to choose the price they're going to sell it at. The market as a whole is going to determine the price, so all of these firms together will determine the price along with the demand. And firms just have to kind of take that as given. Now let's talk about two conditions that we need to be in short-run equilibrium. So, conditions for short-run equilibrium. And there's two things we need to be true for short-run equilibrium. The first is that the market price is such that the market clears. And two, each firm is maximizing its profits at this price. So let's briefly talk about what each of these conditions for short-run equilibrium means. So essentially, what one is saying, let's maybe get a different color here. What one is saying is that the industry is at equilibrium. So quantity demand equals quantity supplied. So that's what that first one's kind of saying. So the market clears in our industry. The second one it's saying is each firm is maximizing its profit. Well, we know that means each firm is producing where marginal revenue equals marginal cost. If price is greater than the average variable cost, because we have that shutdown point. All right, so these are our conditions for short-run equilibrium. And as I mentioned before, it means we can have kind of three different types of short-run equilibriums. So let's go back to the pen color. All right, so three types of short-run equilibriums. One, where profit is greater than zero. So a lot of times we use pi in economics for profit, so pi is greater than zero. Two, profit equals zero. So again, pi equals zero here. We're always talking about economic profit, not accounting profit when we're talking about profit in this course. And the final one is if profits are less than zero, which means profits are negative or you're making losses. So let's talk about these three different types of equilibriums. All right, so let's draw this first one here. So they're all going to satisfy our conditions that we set out above. So remember, with perfect competition, we draw two graphs. We have the industry over here. We have an individual firm over here. Price of the industry, capital Q for the quantity that the industry as a whole is producing. And we have price and quantity for the firm. And I usually use lowercase q to give an idea of the production for an individual firm as opposed to the industry as a whole. All right, so we have our supply and demand curves on the left-hand side, just like we learned a while ago in chapter 3, I think it was. To be at a short-run equilibrium, we need a market clearing price. So this price is where quantity supplied equals quantity demanded. So we have that first condition met here. I'm just going to tidy this Q up a bit. So remember, firms take, given our assumptions of perfect competition in general, firms are price takers. Those first two assumptions meant that firms were price takers. And so this whole industry determines this price level the firms face. And so the firm's demand curve is perfectly elastic. So the demand equals this price that we came up with, and it equals the marginal revenue. So the firm can sell as much as they want, and they always get this P star. Okay, so then we learned about these kind of U-shaped cost curves. So remember, that's because of, at the beginning, we had increasing marginal product, and then this diminishing marginal product assumption kicked in, and so that meant costs would start to rise as we produced more. All right, so we had this marginal cost curve that looks something like this. Here's our average total cost curve, that U-shaped. Marginal cost is going through the minimum point of that average total cost. And then let's draw our average variable cost curve right there. Okay, so now we've satisfied this first condition such that we have this market clearing price in the industry that we talked about over here. Now we need this second assumption to hold, and that's that firms are producing at a quantity that maximizes profits or minimizes losses. And so remember, this profit maximizing condition is marginal revenue equals marginal cost. So at this point right here, marginal revenue equals marginal cost, and this is our criteria for maximizing profit. So this is how much this firm should be making. So small q star. Then we need to figure out what the profit's going to be. And so remember that profit equals total revenue minus total cost. Profit equals total revenue minus total cost. So let's just scroll down for a second. We'll come back up. Again, pi is just our symbol for profit. So total revenue, remember, is just price times quantity. And total cost, another way of thinking about total cost is the average total cost times the quantity. Right? So if you take the average and multiply by how much we produce, we're going to get the total cost. So in this case, we can collect that Q outside, and we've been calling it lowercase q star for the firm in this case, and we can multiply it by price minus average total cost. So this is the area that we're going to draw on this graph. So let's scroll up a bit. So we need to figure out what the average total cost is at Q star level of production. So all we have to do is go up, up, up to where this Q star equals this average total cost, and then we go to the left-hand side. This is the average cost per unit when we're producing Q star amount of the good. We know that this blue line here, as we drew over here, is equal to P star. So this area right here is the distance between price and average total cost. And then we're going to multiply it by the quantity. So this is like taking the profit per unit and multiplying it by how much we produce. And that's going to equal this area, this rectangle, right across here. So the length is Q star, and the height or the width or whatever you want to call it is P star minus C. So that's how we get that area. So this is what perfect competition looks like in the short run when you're making economic profit. All right, next we can talk about the second type, where there's zero economic profit. So let's go back to this blue pen. So short run when profit equals 0. So we're going to draw two graphs again. Again, we have this firm on the right-hand side. We have the industry or the market as a whole on the left-hand side. P in capital Q, P in lowercase q, upward sloping supply curve, downward sloping demand curve for the market as a whole, Q star for the industry, P star for the industry, which determines the price that all the firms face. This is the demand curve from the firms, which equals marginal revenue, which equals P star. And now we're going to draw it when profit equals 0. So here, profit equals, just going to scroll down a bit, like we just talked about, Q star times price minus ATC. So we can talk a bit about something we learned last time, that if price is above ATC, then this term in brackets is positive, which means profit's positive. Scroll down a bit. So if price is greater than ATC, we learned that profit is greater than 0. Now we can think of if price equals ATC, then this term in brackets that we see is going to be equal to 0, and multiplying anything by 0 gives you 0. So this is the one we're going to draw right now. So let's scroll up. Here's that marginal cost curve. Remember, it goes to the minimum point of the ATC curve. And now we need price to be exactly equal to ATC when we're going to produce. And we know that we're going to produce where marginal revenue equals marginal cost. I think we did that in red last time, so let's keep doing that. We know we're going to produce at this point here, which means that we know that the ATC has to look something like this. So if 0 economic profit means the marginal cost equals marginal revenue at exactly the point that this marginal cost curve goes through the minimum point of our average total cost. And so here profit equals 0 because price equals average total cost, which means you don't really have an area to shade in. So this is what a short run equilibrium would look like when profit equals 0. And finally, we had the last case, where we're going to have, let's see how I wrote it, short run when profit is less than 0. And now for this to be true, we need the price to be less than the average total cost, because then this term in brackets that we've been talking about, again, sorry that it's getting a bit messy, if that's negative, then profit's going to be negative. But the key is that we don't want to shut down here, or we're going to draw it such that we're not going to shut down, but we still want to stay open in the short run because we're at least making our average variable costs. So we're at least paying for the cost of opening up that day, because remember, in the short run, these fixed costs are sunk. We can't use these fixed costs when we're making decisions in the short run. So let's draw our two graphs again. Price and quantity for the market / industry. I think we've been calling it the industry above. Then we have the price and the quantity for the firm. It's a short run equilibrium, so we need to be at equilibrium on this left-hand side. We need to be at a price such that quantity supplied equals quantity demanded. That determines this price level that firms take as given, since they're price takers. So demand equals marginal revenue equals price. And here they're making negative profits. So negative profits means price is less than average total cost. But we need to be greater than average variable cost if we want to open up. I'll just erase that part for now. So that's going to mean profit is less than 0. Okay, so let's draw this curve, marginal cost curve. And in order for price to be less than average total cost, we know that we're going to be producing at a point where marginal revenue equals marginal cost, which means that point has to be below this average total cost curve. So here's the average total cost curve. We know that we're going to be producing where marginal revenue equals marginal cost. That's our optimization criteria. So we're going to be producing Q star. Now we can figure out, profit, or in this case is losses. So we can go up to our average total cost curve. This is the cost per unit, the average cost per unit of production. So now we're figuring out profit again. In this case, it happens to be a loss since the average total cost per unit is above the price or the marginal revenue per unit. And so this area right here is going to be our profit, which in this case happens to be losses. So again, that's just this area. The profit equals Q star times price minus average total cost, so times average profit per unit. But now, this average total cost per unit is above the price, so we're making a loss on every unit we sell. Now we're kind of missing one important curve here. We could be missing one important curve that tells us we still want to be open. Right? So remember, in the short run, we still want to be open as long as this price is greater than the average variable cost. And so this is a more complete graph of these losses, in the sense we know that we don't want to shut down because the price is at least higher than that average variable cost. So we don't want to open up. So, sorry, we do want to open up. All right, so in this video, I'm just going to scroll up to the top. We talked about the assumptions of perfect competition. So there's many buyers, there's many sellers. That, combined with the fact that they're homogeneous goods, or all goods are the same that are sold in this market, means that individual firms are price takers, that they don't get to set their own price. They take the price as given by the market. And this third condition is going to really matter when we talk about long-run equilibrium, and it's that firms can freely enter or exit the market. The two conditions for a short-run equilibrium in perfect competition is that the market clears in the industry. So quantity supplied equals quantity demanded in the industry, and the price is such that that's true. And two, that each firm is maximizing its profit at this price, which essentially means that they're producing where marginal revenue equals marginal cost, provided they're at least making their average variable cost. So that means we're going to have three types of short-run equilibriums. We're going to have one where profit equals 0. We're going to have one that profit is greater than 0, and one that profit is less than 0. These are all short-run equilibriums because those two conditions are met. These two conditions that we were just saying. It's an equilibrium in the industry and firms are maximizing their profit, or similarly, they're minimizing their losses. So we can have these three types of short-run equilibriums. This first one is where firms are making positive profits in the short run. This is going to happen where price is above average total cost. The second short-run equilibrium that we talked about is where firms are just breaking even in terms of economic profit. And here, the price is equal to the marginal cost and equal to the average total cost. And finally, we had a short run when profit is less than 0. So again, the industry is in short-run equilibrium on the left-hand side, or it's in equilibrium on the left-hand side. And the right-hand side, we're producing where marginal revenue equals marginal costs, but now the price is below the average total cost, which means we're making a loss in every unit. In this case, we still want to be open because this price is above this average variable cost. And so as long as we're making the average variable cost at a certain level of production, then we're still going to be open even if we're making losses, because we're minimizing our losses. That has to do with that short-run firm supply curve, which we talked about in class. So these are the three short-run equilibriums for perfect competition.